Hey everyone, so for my AP Physics YouTube review, I will be doing it on simple harmonic motion oscillation. And my name is Michael Chu from 4th period. And my learning objective is 3B34, which is the student is able to construct a qualitative and or quantitative explanation of oscillatory behavior given evidence of a restoring force. So for my question, I got it off of AP1 Oscillation, which is an online PDF. And the question says, a disk with a mass m, a radius r, and a rotational inertia of I equals 1/2 mr squared is attached to a horizontal spring which has a spring constant of k. When the spring constant is stretched by a distance x and then released from rest, the disc rolls without slipping while the spring is attached to the frictionless axle within the center of the disc. So basically, when you looking at the picture, you can see that it is at an equilibrium where the disc is at rest and there's no movement from the spring or the disc at all. But it's saying that if you stretch the string to the left with the disc and then release it, the disc will start rolling. So our first question is to calculate the maximum translational velocity of the disc in terms of m, r, x, and k. So for this problem, we can use the conservation of energy, where energy will be constant. So initially, the total energy, all the total energy will be potential energy. And this is because when you stretch the spring to the left, all the energy is stored within the spring and there's no movement from the disc at all. So there's only potential energy initially. And then when we go to the final energy, since energy is always constant, it has to equal potential energy initial. So all the energy from the potential initial will be transferred into kinetic energy final plus kinetic energy, rotational kinetic energy. And there's rotational kinetic energy because you can, from the problem, it tells you that the disc is rolling. So there's rotational kinetic energy. Okay, now we can just plug in all the equations into this expression. So initial potential energy is 1/2 k x squared. And this is due to Hooke's law, where k is the constant and x is the distance. X equals KEF, which is kinetic energy, so it's 1/2 mv squared, plus rotational kinetic, which is 1/2 I, which is I is rotational inertia, and omega, which is angular velocity square. Now, in the problem, it gives you that I equals 1/2 mr squared, so you can plug that in. So it's 1/2 kx squared equals 1/2 mv squared plus 1/2 times 1/2 mr squared from the problem. And then for the, do you guys remember the formula for angular velocity? Well, it's v over r, and that's it. And then you square it. So now you can just simplify it. You can cancel out the r squared and then simplify it further. So 1/2 times 1/2 is 1/4. So it's 1/4 times mv squared. And then now, since you're trying to find velocity, you have to bring it outside. So it's v squared over 1/2 m plus 1/4 m. So now if you simplify further, it's 1/2 x squared equals v squared. And then this becomes 3/4 m. And now you have to isolate v squared, right? So get rid of 3/4 m, move it to the other side. So the final answer will be v max equals the square root. The square root is from the v squared, 2k x squared over 3m. And since there's an x squared and then there's a square root, it becomes x. So you can bring that outside. So it's the final answer is V max equals x times square root of 2k over 3m. And then, so the second question is, what will happen to the period of this motion if spring constant k increases? Well, for this, you need to know the spring formula of an oscillation. Do you guys remember that? Well, it's T equals 2 pi square root of m over k. So it says that spring constant k increases. So if you increase k, that means that the total value within the square root will decrease since you're dividing it by that value of k. So that means that the t will have to increase, the period will decrease. Another way of saying this is that the last problem, if you increase k, that means that there's a higher velocity within the disc that's rolling. That means that if the disc is rolling faster, that means the time it takes for one oscillation will decrease. So period will decrease. Thanks for watching, and that'll be it.